Okay, here we go. There's that side. So let's turn the page. Okay, so here we go. American Red Cross, 11% of the population in the U.S. has type B blood. So this is P equals 0.11 and Q equals 0.89. I'll remind you, 1 minus 0.11 gives me 0.89. That's an 11, not a 4 or an H or whatever. Okay, how many blood donors should the American Red Cross expect to collect until it gets a type B blood? All right, I'll remind you, formula page, expected value. We want our first success. This means it's geometric. To find the geometric mean is 1 over P. So this is 1 over P equals 1 over 0.11 equals 9.09, wasn't it? 9.09 donors. You can do 9.01 or you can round that up to 10, but I'm going to leave it as 9.09 for right now. Okay, then it asks, what is the probability that the 10th blood donor is the first donor? Still again, it's a distribution. Okay, so we've got 9 people, 0.89, that are not type B positive or type B blood. And then we finally come up with our 0.11 to the first. So this is 0.89 raised to the 9th times 0.11, and that's about 0.0385%. 0.0385, not percent, but 0.0385. Okay, then we come to number 5. What's the probability that exactly 2 of the first 20 blood donors have type B blood? Okay, is this binomial or geometric? Well, these two were geometric. This is binomial. These two were geometric. This one's binomial. N equals 20, X equals 2, P equals 0.11, Q equals 0.89. You probably don't have to put the Q, but I do. So we're doing probability that X equals 2 is binomial PDF, because it said exactly when we want the probability density function. So using our handy dandy calculator, second distribution, go up to A, enter. Well, looky there, the numbers are already in there for us. Isn't that quaint? So 20 trials, P is 0.11. We want exactly 2, we enter. So let's write that on our paper here. 20, comma, 0.11, comma, 2, close, equals, enter, 0.282. Okay, small probability. Now, number 6 says what's the probability that at least 2 of the first 10 blood donors? Okay, so it says at least. And again, at least, more than, less than, whatever. We've got to do the CDF. So N now is 10. X is greater than or equal to 2 because it says at least, means 2, 3, 4, 5, 6, 7, 8, 9, 10. But we're doing, again, the complement. P is 0.11. You don't have to, I'm not even going to write the Q this time. So the probability of X being greater than or equal to 2 equals 1 minus the probability of X being less than 2, because it's the complement. And so here's our binomial CDF of 10.11 and 2. Whoops, sorry, 1. You're right, I wasn't paying attention. Second distribution, bet it's still there. Oh, it's not. 10, enter, 0.11, enter, 1. Now we want 1 because we want the first number less than 2. The first number less than 2, which is 1, which means we're finding the area of our curve here between 0 and 1. It goes all the way up to 2, but it doesn't include 2. And so that's 1, that's points. So I'm going to subtract 1 from that, and I get 0.303, sorry. So this answer is 0.303. 0.03. Now, real quick, some of you said there's a negative there. Yeah, there is, because I subtracted this minus 1 instead of 1 minus that number. It's no big deal. I did this in class the other day. 1 minus this number is the same thing as this. Just drop the negative sign. Whew, man, I'm about to run out of breath. I'm going so fast. Here we go. Number 7. So we have 150 donors. Assuming this is typical number, what would be the mean and standard deviation? Okay, fixed number. Fixed number, binomial. So binomial distribution is NP, the number of donors times the probability. So my mean, my mu, is going to be NP, which is 150 times 0.11, which is 16.5 donors. You can do the multiplication yourself. That's 16.5 donors. Surprised by the low number of type B blood donors at the blood drive, the American Red Cross wonders, is the 11% too high for your area? How many type B blood donors would it take to convince you that this estimate might be too high? Okay, we have 16.5 that are type B. That means we have roughly 133.5 that are not type B. So we have enough. We have 10 successes, more than 10 successes, more than 10 failures. We can use a normal model. So we're going to use our numbers here. Oh, I forgot. Yep, you're yelling at me. You didn't find. Okay, here's my sigma. Sorry. I forgot to do my sigma. This, according to our handy dandy sheet, is NPQ, square root of. So this is the square root of 150 times 0.11 times 0.89. Let's see. Clear. Let's get all that madness out of the way. Second square root. 150 times 0.11 times 0.89 is 3.83. Sorry. So 3.83 donors. Okay, so here we go. Here's my normal model. Here's my mean. Here's my standard deviation. And it says, how many would we expect to think that 11% is too high? So we need to go below this. And so we're going to subtract 16.5 minus 3.83, and that gives us, is that right? Yeah, that gives us 12.67. Then subtract 3.83 again, and that gives us 8.84. Now I'm going to stop there because we only need to go 2 standard deviations outside of the mean. That's what we consider unusual. So anything below, because this is really close to 9, we could say anything below 9 donors. Or we could say any amount. Probably should have said any amount below 9 donors, or any amount 8 or below, we would consider unusual. Okay, any number 9 or below 9, or 8 or below, because 9 would be right here. So 9 wouldn't be unusual because it's within the 2 standard deviations. Even if we'd have rounded this to 17 and this we'd have rounded to 4, that would have made this 13, and 13 minus 4 would have made that 9, and it'd have to be below 9. Have to be below 9 or 8 or below. We would consider unusual. Otherwise, I think the estimate's an okay with us. All right. Okay, I hope you understand all that. Now I got to print off the review.